So when people are doing a experiment or a study of some sort, they have to determine the research question, determine what variables to test, then they'll run statistical tests, and they will get this value called the p-value. So the p-value is basically a calculation of probability, and it tells you the probability of an event happening. Graphically, the p-value is the area in the tail of a probability distribution. It's calculated when you run a hypothesis test, and it is the area to the right of the test statistic. If you're using what is called a two-tailed test, it's the area to the left and to the right. So the p-value is indicating the likelihood that the change in your data occurred because of something influencing it other than chance. So you're using this data to assess whether your experiment caused a change and whether that change is a result of whatever kind of experimental setup you had or random chance. So statistical significance is set at a value that is less than 0.05 at the very least. If it's less than 0.01, that's an even better result because the likelihood of this being due to random chance is very, very small at that point. So this is indicating that it happened because of the intervention and that there is a relationship between the variables that you are studying. But you have to be very careful with these interpretations because just because you might have variables that are correlated with each other, it doesn't mean that one caused the other. There could be other variables influencing your data, or you could have biases in your data. Your sample could be too small. You could have biases in the sample that you collected, your measurements. So these are things to be careful with. So let's look at an example. Say the research question is, does having a review session improve exam scores? And the alternative hypothesis would be that having a review session does improve exam scores. The null hypothesis would be that review sessions do not improve exam scores. And then you do your actual experiment. You have a group of 1,000 students that are divided and they're tested for their physical anthropology understanding. And group A has a review session before the exam. Group B does not have a review session. The scores in group A on average are 10 points higher than the scores in group B. So you use a statistical test, and this shows that P is less than 0.01. So that means that your results are statistically significant and that your alternative hypothesis that review sessions improve exam scores can be accepted, and your data is supporting that. So we have to consider the sample size. Larger sample sizes are more accurate. So having a sample size of 1,000 is a lot more reliable than 100. And we have to consider other variables that could be influencing this. So if 50% of group A consists of physical anthropology majors, now that might have influenced the results.